Hey guys, these are your notes on covalent bonding, but before we get into a new type, let's review ionic bonds. So as a quick reminder, you should be filling out the guided notes as we go through this slideshow. So quick review of ionic bonds. Remember that in ionic compounds, we are transferring electrons. They're either being given away or being taken, kind of like the example where we talked about a toy with kids. They either give away their toy or it gets taken from them or they take it from somebody else. So ionic compounds are made up of a metal and a non-metal. So some examples here, calcium fluoride, iron 2 oxide. Notice the "ide" ending of ionic compounds. So now as we get into covalent bonding, we're now making covalent compounds. And this time, these are made up of a non-metal and another non-metal. So now they are going to share electrons. So this is covalent bonding. Think of the prefix co means together. So they're bonding together or they're sharing those electrons together. So when we're naming our covalent compounds, you're going to see some similarities and some differences with ionic compounds. So just like we did before, you start with the element name for the first element. For the second element, you use the "ide" name. The difference is here, the elements we're using are going to be different. And the really big difference is the prefixes. So you're going to use prefixes to designate the number of atoms that there are in each one. But a couple things, and we'll address some examples with both of these. First of all, do not use the word mono as a prefix for the first element. You can use it as the second. Think carbon monoxide has one oxygen, so we use it for the second word. And then if you have AO or OO, you're going to turn it into just strictly an O. So your example, again, we could use carbon monoxide. You're not saying monoxide, you're just saying monoxide. So that double O turns into a single O. So here's our prefix chart. So you have a spot for this in your notes, but this was also at the top of your vocab for this unit. So I want you to pause here, fill out your notes, and then also go check your work on your vocab to make sure you have the correct prefixes because you're going to use these a lot as we do our practice problems and also as you do problems on your own for stamps. Okay, so hopefully you've checked your work and you filled out your notes with these prefixes. Now let's start using them. So first of all, if we look at this compound, N2O3, what is the first element's name? So it's nitrogen, and then the "ide" is going to be oxide. So far we have nitrogen oxide, but now we have to determine our prefixes. So the prefix 2 is di, the prefix 3 is tri. So we're going to get dinitrogen trioxide. Okay, let's do another one. So now we have P4S10. So once again, what's the first element? The first element is phosphorus, and there's 4 of them. And then the second element is sulfur, which we're going to rename as sulfide, and there's 10 of them. So our name, take a minute, think in your head. If you got tetraphosphorus decasulfide, you are correct. That one's big. That's a mouthful. All right, let's do another example. Remember that this one's different. So we have carbon, and we only have 1, and we have fluorine or fluoride, and we only have 4. So mono, though, does not get used for the first one. We're not going to say monocarbon. We're just going to say carbon. So our correct answer for naming is carbon tetrafluoride. Okay, let's do another one. So PCl5, phosphorus pentachloride. Another one, Cl2O7, and this goes into that hint of the AO or OO. We just turn it into strictly an O. So Cl2O7 is going to be dichlorine heptoxide. So we're not saying hepto-oxide or hepta-oxide, we're saying heptoxide. So we're combining it. Oops, sorry. And lastly, we have P4O6. So try this one on your own. And if you got tetraphosphorus hexoxide, you are correct. And that is all for these notes.